Hello everyone, my name is Horace, and in this video we're going to be going through LeetCode number 2, add two numbers. For this problem, we're given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order and each of their nodes contains a single digit. We want to add the two numbers and return the sum as a linked list. We can assume that the two numbers don't contain any leading zeros, except the number 0 itself. We can go ahead and look at some examples to get a better understanding of the problem itself. So for this example, you can see the visual representation of the linked lists themselves. We have L1 and L2, and we simply want to add up the values of the linked list. So for the first one, we have 2 plus 5 equals 7. For the second one, we have 4 plus 6, but that equals 10. Remember, we can't have a two-digit number, so we'll simply take the remainder mod 10, in this case it's 0, and we'll carry the quotient, which is 1. Then for the last one, we have 3 plus 4 plus 1 equals 8. So this is how we get the linked list 708. It's important to note that there are a few cases for this problem. So for the first case, we have that L1 is greater in length than L2. The second case is that L1 is less than L2 in length. And then the third one is that they're equal. The example that we did earlier falls into case 3. So how do we deal with each of the cases? Because the length of the second linked list is less than the first one, we can't really add a nil node and one with a value. So whenever we see a node that is nil, we're simply going to replace it with a 0. This way we get the correct linked list that is returned. Similarly, we can replace any nil nodes in the first linked list with a 0. For the third case, we don't need to do anything special, but we do need to always keep track of the carry. So I'll give you an example of a situation where we would have a carry. So suppose we have 23 plus 9. Well, 3 plus 9 is 12. So we write the 2 here, and then we carry the 1. Then we do 1 plus 2, which is just 3. So we get a result of 32. The way we got the values when we did a carry are as follows. So we simply did 3 plus 9, which is 12. We always know that the value here is going to be the remainder mod 10 of this value. So really we have 12 mod 10, which is 2. We also know that the carry value is going to be the quotient of this number divided by 10. So we have 12 integer division by 10, which is 1. It also might be noteworthy to point out that the carry in this case can ever really be 1, because at most we have 9 plus 9, which is 18, and we have a carry of 1. Okay, now that we have some intuition as to the cases and how the carry is going to work, we can just construct a separate linked list with all the values after we traverse them. Now, although a linked list traversal will simply take O of n time, we're also taking O of n space if we want to construct a completely new linked list. We can simply adjust the linked list in place, and then we'll have a solution that will have O of 1 space complexity. So let's revisit the second example. Let's suppose we're always going to return the first linked list. So in this case, it's smaller than the second linked list. Really what we can do is we can simply swap the links between the first linked list and the second linked list nodes. This way, if the second linked list is greater in length than the first linked list, then we can simply use those nodes in the second linked list to build the first linked list. With that being said, we have some intuition as to how the algorithm will work, so we can go ahead and try to code it up. Okay, so we can go ahead and start to code up the solution. Since we said that we're going to return the first linked list, we can simply point our head to the first linked list. We can also initialize our carry value to be false. Next, recall when we're going to traverse a linked list. It's exactly when the first linked list or the second linked list is not none. Thus, we can write while L1 or L2. Next, we're going to check if the length of the first linked list is less than the second linked list. If so, we're going to perform swaps. So we're going to check if the L1 node points to nil, so if not, L1.next. And we know that we have a L2 node. We can simply swap them, so L1.next, L2.next equals L2.next, L1.next. Next, we need to ensure that whenever we have a nil node, we're replacing it with 0, because we can't sum a nil value. We can store these values in v1 and v2 respectively, so v1 is going to be the value if it exists. Otherwise, if it's null, we're going to just set it to 0. Similarly, v2 is going to be L2.val if L2, the node, exists. Otherwise, we're going to set it to 0. Now that we have our v1 and v2 values, we can check if we need to carry any value forward. So we can use a helpful command called divmod, and this will return a tuple with a quotient and the remainder of the values that we pass in. So we want to update carry and L1.val. And we can say that this is the div mod of v1 plus v2 plus carry mod 10. Finally, we can traverse the linked list. So we can say L1 is equal to its next pointer if it exists. Otherwise, we'll say that it's none. And similarly for the second linked list. Then we can go ahead and return the head of the linked list. Now this code might seem correct, but we also have to take into account whenever we have a carry at the end of a linked list. That means if we have a carry on the last summation, we're not going to actually be adding it or updating it in the first linked list. Thus, we need to keep track of the previous linked list node. So once the loop finishes, we know that we've traversed both linked lists. And if there is a carry, we can simply add it to the end of the list. Now this code should be correct, so we can submit it. And as you can see, it's accepted. So hopefully this video helped you and you learned something, and I'll see you soon.